pipe sizing for a given flow rate, pipe length, and head losses by using Darcy Weisbach equation and Colebrook's equation. Now, if you're doing design, you know that the pipe length, you can know the pipe length from a particular point to another point. You can also determine also you can assume a minimal heat loss, a head loss, which is that one can be known. That is a minimal head loss that it should not exceed so head loss. You can know that one, but you cannot know the size of the pipe. So we can calculate the size of pipe using this method. Now, the first thing we do, we assume an initial value of f, which is f subscript k. Then we use this value of f to calculate the diameter for this f subscript k value. Now, using this equation, d equal to 8 times the frictional force, the frictional factor, times the length of the pipe times the flow rate square, all over the pressure drop divided by the flow pressure drop divided by acceleration due to gravity divide by pi raised to power 2, all raised to power 1/5. Now, you also use this friction factor to calculate the friction factor and the diameter, the internal diameter which you have calculated, to calculate the Reynolds number for this condition. Now, from this equation of from this Reynolds equation, there is the Reynolds number equation, which is the velocity times the diameter divided by the kinematic viscosity. Now, inserting the formula for velocity, which is 4q divided by pi divided by d square, into this equation, you have the Reynolds number in terms of flow rate, which is q. That is 4q all over pi dv. Now you get to this place, you know, you calculate. Now you find a new f subscript k plus 1 value. That is, you find a new value using Colebrook's equation. Now you would discontinue this calculation if f subscript k plus 1 is equal to f subscript k. If they are not equal, then you continue the process till you get to the point where they will be equal. Then you knew that you have gotten the value for d and the value for f. So I will use Visual Basic to write a program to do this task. After I'm done with that, I will also use Excel to verify what I got, to see if Excel will give me a close to what this the program the program I created was able to do too. That is, I use Excel to verify what the program is doing, whether it gives the actual whether the answer it gave was equal to that of the Excel. If there is any error, I will point it out. Maybe subsequently I'll go back to the program and see where the error is coming from. So now let's begin. Now I've opened the Visual Basic environment. This is this series of the friction factor, guys, on how to create friction factor, on how to calculate friction factor using Visual Basic. This is a series. This is the program which I have been running. So what will happen is that I will create a form. I'll create a form project. I'll open project, then I'll add a form. I'll enlarge the form. I'll give the name of the form FMR pipe sizing. Say enter. Now I will change the color of the form to blue. Then I will change the font style. The font style and size. I'll change this to Time Roman. I'll change this to bold. The font style to bold. The font size I'll make it 16. And I'll say okay. Then what I will do is that I'll add a frame to the form. I'll change the color of this form to the back color to blue, which is highlights. I will call this caption pipe sizing. Now then for the form, I'll make the caption. I'll call the caption calculating let me just say calculating for now. Maybe calculating the internal diameter of the pipe. Now I can change the caption later, but let me leave it at this. Let me move it to the center. I can change it and make it capital letter later. Then now what I will do now, I'll go to this form, open it, I'll copy this, I'll copy this, I'll copy this, I'll copy this, then I come here, copy. What I'll go when I go there, paste it and modify the pipe sizing form. Now let me expand it a little. I'll expand it a little. Then I paste. So then I paste. So there are things like this. Okay, this should be number. This pressure drop should be at this part. I will knock off this outer diameter, internal diameter option buttons. I will knock off. I will only leave this internal diameter, bring it to this other side. What will happen is that let me pause and modify. Let me pause and modify the form, then, so that I won't waste your time modifying the form, because there are some other videos which I've done, which have modified forms. You can look at them, and if you want to learn more on how to modify form, or you can also on the comment on comment, you can comment that I should show you how I adjusted the form. But for me not to waste your time, or waste the time, or increase the time for the video, let me pause and edit the form. Okay, I'm done arranging the forms. This is the form now. I've changed this into pipe sizing, so it's not that calculating that long statements now. So what will happen? This is it now. Now let me go and code this. So what I will do is that I will come to this, I'll copy the whole of this, and now add edit. Copy the whole of this, then edit. I'll go there and paste it. Let me see if I copy. This one is not part of it again, so I do not need to copy it. So I'm coming to edit. I'll just copy from here up here. Okay, I don't need to copy this because it will be a duplicate. Let me copy from here down to this point. So I'll copy, I'll go to the form, let me remove this because it will be duplicates now. Let me now paste. So what I will do now is to change the address of the form. Now I will change the address of this form here to pipe sizing. So I'll change it. This thing will now be change it. I'll change it to pipe sizing, so that if you click it will hide pipe sizing form, not the other form. So it will be the name of the form or any object. It kind of is a property that there is a kind of, it's like an address property that tells you, okay, this is what you want, this is what you want such a method to act on, like the hide method. Okay, this is the property you want it to act on. Because if I even leave that name there, if I say hide, it will only hide that other one, and we'll be having issue with the program. So now I also need to change the address of this one. I will delete it, then change it to pipe sizing. I'll do same to this one. I will delete it, change it to pipe sizing. So these are what I already did here. When you check, the reason why I didn't carry that other, the option buttons, I've deleted the option buttons, so it will not be functional here, because when you check the form, there is no option button for outside and the internal diameter. Now when you look at the form again, okay, you have kinematic, flow, specific, and all this. So I needed to look at them to see, because there are some I discarded, to know which one is not relevant. Let me look at this now, then so you understand what I'm saying. This one is not relevant here. I needed to delete it because I've already deleted it on that form. This option outside diameter 0, so it's not relevant here again. I need to delete it, because if I don't delete it, it will have an issue. So which is what let me check through this once again. I have absolute, let me see, I have internal diameter, I don't have outside diameter in my form now, so I need to delete this. I don't have pipe thickness there. So let me pause and do this deleting. Okay, let me delete this one so you know what I'm doing. So because that is what I will do in subsequent in this other s if, because the what is here is the same thing that is here, so there is no need repeating it. So I will just pause. Let me see if I'm done with this one now. Flow velocity is there. Let me check. Flow velocity is there. Okay, let me go back. Let me pause and let me pause the video. So I've done deleting those ones that are not necessary here, that are not part of the part of what is in the form. So I've taken them off. Let me check if, let me run the, okay, I've not added let me open this form, right click the menu editor. Now I needed to add, let me click here, insert, so I will add pipe sizing. This is for caption, pipe. For caption you can put space, pipe sizing. Let me make the pipe sizing, let me make the first P capital letter. No, pipe sizing. Then I'll make sure there is no space here. Say pipe sizing for the name. Now let me say next. Then here I needed to indent it once. Then next I need to indent it 2 times so that it will be under this pipe sizing. So what I'll put there is, I'll say using Colebrook Colebrook's white equation. So that is what I'll use. So here now I can just paste this one here as Colebrook's white equation. Now let me say okay. So let me look at it. So this is it. Using Colebrook's white equation. Now let me double click. So Colebrook's white equation. Okay, so it's there. So I've added it there. Okay, you have FRM pipe sizing dot show, so that when you click that it will show the pipes. Look at it now. If I come here, click this, not found. Okay, I needed to delete this one. I didn't delete this one. I did not look here thoroughly. Let me delete it now. It's not part of it, so that was why I did not check thoroughly. Let me still check again, because now you have, okay, this one is not part of it. before it will show error too. This thickness is not there. I need to delete them. So I did not modify completely. I did not check thoroughly, so that was why there are some errors there. Let me see. Okay, it's okay now. So there is no, I've deleted everything that needed to be deleted. So that is that. So this is it. So it's working perfectly well. So great. Now so I needed to code this other listing. So call solver console. So I needed to change this. Let me see. I don't think so this is a duplicate. I'll change this to pipe. I'll change this to pipe sizing. We change it to pipe sizing. Then now I'll create a class. I'll create a class. Where is it? This is it. So I'll call the class pipe sizing. Pipe sizing. That's the name of the class. So sorry, I'll call it CLS pipe sizing. So it's, I will differentiate it with other ones. I can differentiate it. Now CLS pipe sizing. So we're done with that. Then now what I'll do is I will go to this. Sorry, I'll go to the class of this. I'll copy from here down to the properties. Now if you want to know how some of these properties are being created, you look at my subsequent videos, you will see how I created some of these properties and some of these, like the way. Also when you look at the subsequent videos, you see how I created this CLS Darcy friction factor, which I'm copying now. So now I'll go to CLS pipe sizing form. I will now paste this. Now this private, I didn't copy the P, so that was why the thing changed red, because if there is an error it will change red. Now let me now look at it and delete those things that are not part of it. Like this one, I've deleted it from the form, so it's not part of this form now. Now pipe length, internal pipe diameter is not supposed to be part of this place because it's what we are looking for. It's what we're looking for, so it's not supposed to be part of that. So you have, let me look at the form. These are things that are in the input section. You have this, you have 6 things. So it's 1, 2, 3, 4, 5, 6. Let me check. So that means that area is supposed to be 6 in number. We have 1, 2, 3, 4, 5. So the 6th one is a pressure drop. So I'll say comma P pressure drop. Now, so pressure drop should be part of this. So now what I'll do, I'll just copy this. I will now go to one of those properties that are not part of this anymore. I will convert one of them. So like this internal diameter is not supposed to be part of this because it's something I'm looking for. So what I will do now is I'll select this, go to edit, find, now click replace button, paste this one, remove P there, so it will now be left with pressure drop. Now I will now say select, let me see, I will select from here to here, then I'll say match. Now what I will do now is I will replace all, so it's 7 here. Close this one, the outer diameter, the pipe thickness, that is from here, and pipe thickness, this one will go off. Now okay, this should be part of it, absolute pipe length. Now I have kinematic. Okay, let me check thoroughly. So all these constants, okay, so okay, this is Reynolds number. This Reynolds number, I needed to confirm if these formulas are, these constants are correct. I need to reconfirm them. So now I will use x 0.8. So x equal to 0.8, y this is greater than this. Okay, let me be sure that is it. So 1 e minus 12. Okay, because that was what is here. Down here say e minus 1 e minus 12. So that is it. So this is equal to this. Okay, now I need to calculate the diameter, so the internal diameter. So an internal diameter, we used this formula. Okay, now we use this formula. Now let me use the snap tools to pick this thing so that I won't be coming here to say copy. Let me go here. Okay, can't paste, so cannot paste. So now that means I'll be opening this. I have D. So definitely this is what I will use. I'll copy. Okay, this I needed to change this into. I need to change the name of the form to pressure. Now I will now copy from here to here. Okay. From here to here, because this other width statement, width and with this form end width is in that other part, so it's here. See width and this. Now let me change this. Let me change this to from pipe sizing. So now I need to add this here. This will be out of the game. If this is this, so then what I'm looking for here, this is pressure drop. This pressure drop. I will knock off this. These are duplicates. I don't need to calculate pressure drop. Let me look at this. This is okay. Let me remove this. Now let me work on this. I'm looking for D, so I will add D to this place. I say comma D as double. Then now make here say D. D should be equal to I'll call this this is the friction factor. The friction factor. Let me see. 8 times the friction factor. Now, okay. There should be a constant for D. And that is what I will do now. I'll copy this. Is it that one? Okay, let me copy this. Copy. Paste. I'll change acceleration due to gravity. This to internal diameter. Now I will now copy this and replace the whole of this with it. Replace the whole of this with internal diameter. Now I will now look for the constant for internal diameter. Now you know the constant for velocity is this. The constant for velocity is this. So what? So let me open one note to make a point here. That's all. I will use this formula now because this my program is different. So the there is a constant for velocity, k q all over d square. Now the hf is the same thing as f k l all over d times v square all over 2g. Now we now have the hf, which is the pressure drop, equal to fk l over d times this square is k q square all over d raised to power 5 all over 2g. Now we are left with fk l over d times k q square, sorry, this is d raised to power 4, sorry, it's d raised to power 4. From here it shows that v square is equal to k square q square all over d raised to power 4. So substituting this into this, you have this times this square all over 2g d raised to power 4. So the whole equation will now be fk l. This l is in feet, this is in feet, and this is in inches. So we needed to change this to inches, so we multiply by 12 d, so that this thing will cancel out as, so this will cancel out as dimensionless. So you now have k square q square all over 2g d4 d raised to power 4. Then fk will be the same thing as, they say 6k square l q raised to power 2 all over 2g d raised to power 5. So this will be, d will now be equal to 6k square f k l q square all over hf g all raised to power 1 over 5. Now let's look at it thoroughly. This cancel, this is 6, this is k square, this is q square, this is l, okay, this is 2g, this is 5. So you have, so it's okay. Now this is the formula we're going to use. Now this is a constant for diameter that we're going to be using now. Now for customary unit is 6k square. For English units is same 6k square. I'm using 6k. Yeah, look, let me use n here because so that it will not be look as if it's the same. This is n, sorry, although this is n here, so it will not look as the same. The k there is just a constant, it's not, this is like this is an index. So that is that. So this is it. So the SI unit will be 500 k square. Because why is 500 is that this one, the L is in meter, so it times it by 1000. The D is in millimeter, so you're changing the is in millimeter, so you're changing the meter to millimeter by times by 1000. This one is in millimeter, so if you times this by 1000 it becomes millimeter. Then these two here divides this to be 5. To be 5. This will be 500. So that is how I got this. Let me go and assist my wife from coming back. So the K square, the K is this. This is for velocity, fluid velocity. So the K is this. Let me copy it and go into a cell. Let me just paste it here. Expand it. You change it to general. No, I just want to see it. Okay. So now, so the value for customary unit 6k square. So let me just put 6 here. So let me call this now is for this, right? Copy this. Let me just paste it here. So for this, the value will now be equal to this. Okay, let me just name this K. This is just 6. Let me leave it on that. So just say this is equal to K raised to power 2 times 6 times this 6 here. Let me make that 6 constant. Now I will now change this value here. So pressing F5 for that, it will be, even if I drag it from here to here, it will still be referencing this 6 here. It has fixed it. It has fixed the D, which is the column, and the row, which is 3. This dollar sign has fixed the D. Guys, has fixed this point. Fixed it at this point. I fixed it at D and 3, so it will not change. Even if I'm dragging this thing down, the value will not change. So what I'll do is to copy. So copy this one for English. This is same thing. So but for English, so English is this is the value for English. Where so this is the value for English. Paste it here. Just drag this here to calculate. Okay. This. Okay. Now drag it, it will not. It will also be referencing the K, because this is a K. So what I'll do now, I'll call the whole of this. I will change the whole of this to K. Let me go to formula bar, go to manage. I look at K. Where is K here now? This is K. I will edit it. I'll say is equal to this, equal to this. So I'll click here to OK it and close. So this one will change, this one. Now what I will do is to drag it. If I drag it, this one has its own different value, this one has its own, this one has its own. So that is it. So it represents from here to here. So that is it. So now I needed to take, okay, this is 6. This is 6, sorry. This is 500. Now that means I'm not going to make this one. I'm not going to fix it. I can fix this one. I can fix that one. Where is the dollar sign? The dollar sign is 4. So I can fix that one. If I move this, it will be changing the rows will be changing. The rows will be changing, but the column will remain the same. Even if at that, if I move it this way, the column, the column will remain the same. But look at it now. If I move it like this, the column will remain the same. Look at the column will remain the same. It will be a constant for. It will even the thing will not be changing. So I can only remove, I can only unfix the rows, so these are these. So now I will use this. I'll copy them as the constants for diameter. So here I will change to that value. Go back. This one will change to that value. Paste. This will also change to this value. So let me bring them closer. Now we have done this. So I can even show you how I got this. I got this, but we don't have that time now. We don't have that time. We don't have that time now. So gotten this. So from here, from this, that means the equation will now be D. D will now be, let me use another form of, let me use another constant. Let me say that will be the constant now for diameter will be, let's say BD FN L Q square divided by this divided by this, all raised to power 1/5.
Yes,
All
Mom.
raised to power 1/5. So this is the constant now, which is this 6k square. So I hope that I didn't omit anything. Hope I did not omit anything. This is this. This is this. This is this. Listen. I hope I did not omit anything. Anything. Now let me go back to this place. So I will now say D. Our D, what is it? D will be equal to internal diameter okay. Now let me just take this thing off. This should be Y. This is Y, frictional force. Y times, there should be times here. Now this should now be diameter this, okay. This should be this. The whole of this is supposed to be in a closed brackets. Let me close it. Now I have this times Y, which is the friction factor, times pipe length. Now I will remove this because that has been taken care of. Times friction factor times flow rate square times flow rate raised to power 2 divided by, let me see, okay, this 2 is off already, so why this 2 is off already, so why is it coming back? Because it has divided this to 12, so to give us 6 here, so why is it always repeating itself here? So it's not supposed to be there. Now divide the whole of this, divide by pressure. We take this one off. divided by pressure drop. Pressure drop. Now this pressure drop here that I left, we're here. This pressure drop, I need to delete them. I need to delete them. Let me see. I need to delete this pressure drop function. Delete it now because okay, I can calculate the pressure drop in kilopascal, but the pressure drop has been given. Divided by pressure drop divided by acceleration due to gravity, so which is this. So I will come here, knock off this whole thing. I will replace it with divide. So this divide by this. Now I don't need this. Now this whole thing raised to power, bracket open and close, 1 all over 5. Now which is this? D. Now I will replace this D with, the whole of this copy because it will be the same thing. So this, I will replace this with that. I will replace this with that. Now what I will change here, this should be, I'll delete this and replace it with English. Replace it with English. I will replace this acceleration due to gravity in customary to English too.
Daddy, are you doing something?
I will delete this because this is given. This is pressure drop. Okay, we need this, so I'll leave it. This is part of the output, so I will leave it. Now here I will replace this one with SI unit. SI unit. I will also replace this with XI units. Now this one is an output for pressure drop that is already has been given. So this one is still relevant here. It's relevant in the sense that this is part of the output. That is pressure drop in kilopascal or in PSI or kilopascal. So it's still part of it. So then okay, it's not supposed to be here. I supposed to permanently delete it here. Is the same thing, the same formula for all of them. So I will copy one. It's just the same thing. So okay, there's a reference. So the expression drop is okay. It's not the same. So just what I will do is okay, or maybe this one doesn't change. The pressure drop is constant. This is a constant. This is a constant. So it will not affect the result. So it will not affect the result. So I'll leave it at that. Then the next thing I'll calculate is the I need the Reynolds number. Now there are Reynolds number here for. Let me copy it. Okay, let me be cutting it. Reynolds number for option customary unit is index 0. I'll come here, paste it here. Paste. Now this is flow rate. This is okay. The internal diameter will change this to D. Change this to D. Use it there. I'll go to that other one. I'll cut this. I'll come to this other one. Paste it here. Paste it here. For English. Then for this other one, I cut it off and paste it for SI units. So here I'll change this to D. Change this to D. I've changed this to D. I will now change. Okay. English, I change this to D. D. I remove this. Okay, I didn't delete this. No, this is not supposed to be here. This one is not for this. So it's well arranged now. I have Reynolds number here. Okay, the other Reynolds number is supposed to be here. Let me copy this one. Go here. Paste. What I'll just change is this English unit to customary unit. Delete this. Choose customary units. Now we have this. We have this flow rate, this and D. So for this this and define it here. And define it here. Let me say comma paste. So having defined it there, now let me see. There is another thing I need to. This is absolute divide by this. This should be D. This should be D. This one should be just only Reynolds number. Let me just see if, yeah, only just Reynolds number. Now let me delete this Reynolds. This function is Reynolds. Okay, let me delete this function. This function is not supposed to be part of it again. I need to delete it. Let me see. Now now we have log this, okay. Log absolute system is divided by this plus this divided by this inside here square, okay. Now this whole thing, let me delete this, change this to this. This should be okay. This is not supposed to be part of it again. This should be changed to D. This should be changed to only Reynolds. Only Reynolds. Okay. Then this is this, okay. So here I'll just include the value for the Reynolds. So I will just say T text Reynolds dot text will be equal to, we'll use round value call this, copy this, come in here, paste it, comma, okay, so now here's another one. dot tx internal. It's not dot, oh, this is comma, dot ts internal diameter dot txt equal to let me just say r. Let's copy this, replace with this. Make this one. D. Then this should be place of this one. Okay, let me verify this value and make a change. This 3160 for Reynolds number. Now, you know, is 4Q. Okay, let me just use snap. Sorry, let me snap this. We copy. Let me copy it. Let me paste it here. So let me verify for English. Let me see if it's correct. Let me say equal to. So I needed to convert this. This flow rate is in gallon per minute. So I need to convert that flow rate to the. I need to convert that flow rate to feet per second. So what I'll do is I'll say equal convert. I'll press the tab key. I'll say 1 comma this is a right gallon. This, then I put this feet raised to power 3. So power this, so this feet, so bracket close. Now we have converted that. Now we multiply it with 4, which is no, not divide. We multiply by 4, which is this 4Q. Now we divide by pi raised to pi. Divide by pi. We divide by the D is in inches, so we'll convert it to feet too. So say convert, bracket open, convert, let's say it's 1 comma this inches, this comma feet. Bracket close. Now divide by, now we needed to convert this stoke, centi-stoke to, need to convert the centi-stoke to feet square. Let me see. Now centi-stoke in feet square is this, that is 1.076 times 10 raised to power 5. So that is what I will use there. Now I will now divide the whole thing by 1.076 e minus 5. Then enter. No, this is supposed to, I'm changing this in, this is stoke. So this, I'm dividing by this. This converting to feet, converting to stoke. Wait, this is stoke. Stoke is in one stoke. Like that, so okay, it's supposed to be times this, times this is supposed to be times one stoke is equal to, okay, no, it's divide. Divide is correct. Divide. Now why is it not giving us? We have this one going to feet cube, divide by pi, divide by this into feet. That's 4. The feet square. Feet cube. So it's not giving me that. Let me see. Okay, let me check the other one. Let me just copy this up and change this to barrel, because the other one is just this that is different. Barrel. Let me see. Barrel. So change to barrel. Oh, I didn't put this in this. I need to change this to minute. That means I need to change that to minutes. I'll divide this by. I need to change it to, because this is still minutes. Now I will divide it by convert. No, not this one. This one is not in minutes. This is not in minutes. This one is in minutes, because this is in gallon per minute. So I've converted to I've converted to gallon to feet. I need to convert to minutes, so I'll divide this by converse of let me say 1 minute to seconds. This is seconds here. Bracket close. Supposed to be divided because in minutes. So I'll change it to minutes. So let me enter. This one is changing. This one I'm changing it to converting it from 1 day to seconds. So this is 92 point. This one is 92.274. This one is correct. But this one is 3162.63. Let me see what they got there. They got 3160. This one is okay. I'll take this one. Okay. That means this is correct. So I'll replace this with this. And then the up one. Okay, the problem why I did not get it before was that I forgot the unit. When I wanted to do this one, I remember that this one is barrel per day, and this one is gallon per minute. So I don't put the conversion for. When you check it now, when you check this one, I didn't put the conversion in minutes. I didn't put the minutes conversion. That was why I didn't get it initially. So now let me copy this and come here. Now this should be, I'm changing this. Should I use this? Should I use this? This one is in meter cube. This is a meter cube. Converting it to let me say millimeter. Converting it to millimeter. Let me see if there is a millimeter cube. Okay, it's like there is no millimeter cube. There is meter cube. Inches, feet. Okay. There is no millimeter, so I can leave this at. I'll change it to feet. Let me see. From this to feet. From this it should be hour. From hour, because it's a meter cube per hour. So then the diameter is in millimeter. Is that millimeter? Let me see. There millimeter. Let me see if there's okay. Let me see if there is. Now this Okay, let me enter. So you have 355. Let me copy this. Copy this, go here. You have 35. Okay, I'll replace this with that. I'll replace it with that. So let me come up here, come up. Now, this is it. So, I'll leave these other ones as they are. Leave them the way they are. Okay. Let me save. Okay, let me just leave this now. Now, we need internal diameter. Let me look at the form again. We need internal diameter. We need this. I've calculated this. I will have this. We need Reynolds number. We need the flow velocity. Okay. Let me see. We need flow velocity. Let me see. Now I have my flow velocity here. This is friction factor here. Okay, for this, let me see. I don't think there is friction factor. Okay, this is flow velocity. So I need to copy this. I'm going to copy this. Let me cut it. Flow velocity. I need to place it. Okay, the flow velocity we have. Okay. That means let me undo. Now for follows, I'll just copy the whole of this. Copy this. Let me just cut it. I'll come here and paste it. Paste it here. So let me see if the flow velocity constants are here. Okay, they're there. So you calculate this. Okay, this one is D. This one is D. This is D2. Now, I've gotten the flow velocity. Let me check the form again. We've gotten Reynolds number, friction factor. Let me go back. So I've gotten the flow velocity, I've gotten friction factor, I've gotten Reynolds number, I've gotten this. Okay, let me see if there's. Let me be sure that I've defined all those things. Am I sure? I've defined D, I've defined Reynolds number. Okay, let me just run and troubleshoot. If there's any issue, let me run it. Now let me go. Okay, I have not created the. Let me close this. I've not created the models. The module. Now just we'll call it M pipe sizing. M pipe sizing, that is what I'll call it. Now in the form, the solver the solver has to this. So this is the address of where it will come here. This is the address of where it will come here. So what I will do is I will go to add a subroutine, a sub procedure. So I will say with form pipe sizing, I will not say end width. Now what I will write here is I'll say D, call it property, let me call it, I will define it as property as CLS, not this CLS, as CLS piping, the phone wants to off. There's no lights. Let me shut down. Let me close it at this point. I will now set the property. Now the property is defined. Okay, it's not set yet. The property equal to new CLS piping, CLS. CLS pipe size. What is it? It's not part of this, so let me upload it. Let me add it. It's not part of it. Look at what I did. I just come here, right click, add, go to add file. Now I will go to my external hard drive. Go to my external hard drive. Open this. Open the CLS piping. Okay, it's inside here. CLS piping. Okay. So it's here now. I've included it. So now let me go back to this. Now let me see whether it will show now. Okay, it's there. Now down. Instead of delaying, let me go to the module for Darcy friction factor and copy this whole thing instead of wasting time, because already I'm wasting a whole of time. Copy the whole of this. Outside diameter is not part of it, so copy this. We'll go to this, paste it. Let me look at it and edit. Okay, I have this, I have specific, I have to absolute. Now I need to add another one. I need to add pressure drop. Look at it there. Now I need to change this to pressure drop. I will delete, and it's pressure drop in okay, let me just say PRE, pressure drop. Okay, this one in fits. Now we have 1, 2, 3, 4, 5, 6. So it's complete. Let me check. Let me check the form. 1, 2, 3, 4, 5, 6. Correct. Let me now go back to this one. We'll copy this, paste here. I now need to run the pipe size. Let me see. The pipe size, the subroutine pipe size. It's not here. No. Okay, let me leave it like that. Let me go back to this. What is this? This is okay. Solver here. Wow. Let me change it to pipe sizing. Change it to pipe sizing. And I'll go here. Let me check again. So you have the pipe sizing here now. Now let me check. I don't have pressure drop. Okay. Pressure drop. Let me go through the work again. Okay. Let me run and debunk if there is any error along the line. There's any error along the line. Let me see. This is 1 5700. This is 1. This absolute pipe roughness is 0.002. The pipe length is 25,000. This is 12.98. Okay, let me see. Okay. This is supposed to be defined, but let me check again what they are saying. I didn't check it yet. Function on left hand side must return variables or objects. Okay. It's a function, so I need to take this one off so that it will not be a function again. Now I need to copy this. I need to copy that and define it here. I'll say comma paste. Now this is so here I needed to put, okay, let me go to this. Okay, there's no need going there. Let me just say .txt fluid velocity dot text will now be equal to, or round it up, let me paste this comma 2 decimal place, close comma. So let me see what I needed to get there. Flow velocity, Reynolds number, friction factor, turn this. Okay, felt. Let me just troubleshoot again. Let me just debunk and see if there is any error again. The process. Now we have 1 for kinematic viscosity. We have for flow rate. We have 5200. This is 1. This one is 0.002. This is 2500. This is 12.98. So we have 937,009.62. So the friction factor is correct. The internal diameter is correct. This, let me check. Let me check. Let me check. So I've opened the problem. You see, just like what I said, this one is given. We assume that this one doesn't exist. This one is not there. This one is given. This one is given. This one is given. This one is given. And the pipe length, you can know the pipe length. Now we now use the frictional loss 12.95. Now we got our velocity was 6.29. Then our internal diameter is 19.25. Here they got here is still, this is 19.25 the diameter. Now you have the Reynolds as 935.688. Well, here we have it as what, 937.009. The friction factor is correct here, which is this. The internal diameter is correct. This one is also correct. So the only error here is this. The flow velocity is also correct because this one is 6.28. Anyway, the error here is not much. So that is that. Let me exit. Let me exit. Now let's use Excel. Let's use Excel to solve it. Let's use Excel to confirm what we got. So let me pause. I want to pause since it's taking time to load. Let me pause it. So now let me begin. I will use the method they used here now. So, but in Excel. So these are the inputs. You know your flow rate. You know the pipe length. You know the kinematic viscosity. You know the specific gravity. You know the pressure drop. You know the absolute pipe diameter. So you are to calculate now. Let me format this 3 column. Now I will just say this one is calculate. Let me make it capital letter. Calculate. Now let me bring this closer. Now the flow rate is in gallon. We need to convert it to feet. So flow rate. Now I'll see is equal to convert. I'll convert the flow rate. I press the tab key. I'll select this, comma. I'll change the gallon. The gallon. Okay, this is capital, sorry. Change the gallon to feet. Raised to power, that is feet, cubic feet. Now I need to put this here again. Now you know this is gallon per minute, so I need to also divide by converting 1 minute. 1 minute to seconds. I'll just select this one. Now close the brackets. So that means I've converted, I just enter. That means I've converted this thing to feet raised to power 3 divided by seconds. Now I will select the whole of this, press format paint, select here. Now we've converted this to feet. Then this other one, the pipe length is okay. Then the kinematic, let me just copy here, paste it here. Now I need to convert this kinematic. This kinematic is in centistoke, and one, okay, let me open this other reasons. Open this. One centistoke. One centistoke. I've used it before. It's okay. Look at it here. 1 centistoke is 1.076 times 10 raised to 1 minus 5 feet square. So that means I will be replacing this with that value. So this, since this is 1 centistoke, so we have 1.076 e raised to power, that is 10 raised to power minus 5. Now this is it. So this is in feet square. Divided by seconds. Now we've gotten this. Now here we assume, is there any other thing I need to, okay, I needed to convert the absolute, so let me say, let me just copy the absolute here. I need to convert it to, let me paste. I need to convert this to feet. Let me change this to feet. I will now say this is equal to convert this, comma, from inches to feet. This is to feet. Bracket close. Now I'll convert it to feet. So the next thing I will do is to assume the F, there is a friction factor. Let me call it, let me spell it completely. Friction factor. Assume the friction factor. Let me assume the friction factor. I will assume it to be 0.008. Sorry. Now Okay, there is no unit for that. There's no units. Then the next thing here is to calculate the internal diameter. Internal diameter. So the internal diameter, look at the formula I'll use. Now we'll say equal to, so bracket open, 8 times. Okay, let me just, since these are the things I'm going to use now, let me define this as Q. Let's say Q1, enter. Okay, no, Q1, this one should be part of, let me say underscore, sorry, underscore, P1 underscore, and let me see, so Q underscore 1. So okay, now let me go to formula. Okay, there is Q before, so I will change it to say equal to this, change it to this, so it's changed now. Close. Then this is V. Let me say close. Let me also change this the V is which one? H4, okay. I will change this to this for V. Now this is it should be E. Let me go back to this E. Okay, E is okay, not the right one. I say equal to, I'll select the E. I'll make it that. Now I've defined it, so let me close. This should be F. So it's equal to this. So I've defined them. So this now will be equal to bracket open 8 times F times let me see, L as pipe length, which is that one, times Q raised to power 2 divide by pressure drop divide by acceleration due to gravity is 32.2. Divided by acceleration to which is 32.2. This is in feet per second square, so divide by pi square. Pi square. Bracket close. Bracket close. Raised to power. Bracket open and close. 1 divided by 5. So enter. Now here is in, this is in feet. Now I will, okay, format this. So the next thing I will do is to calculate the Reynolds number. The Reynolds number. So this should be equal to, now let me pause, let me continue, let me use snap, let me use snap tool, let me use snap tool to copy this Reynolds number. Copy, minimize this. Now let me paste it here. No, let me paste it. Paste. So Reynolds number would be, should be equal to 4 times Q, which is the flow rate, divide by pi, divide by internal diameter, divide by this is internal diameter, divide by V. I've defined V, so divide by V. Now enter. Now this one I needed to change it to, let me change it to D. Here now should be D. Let me see if I've defined, if I've defined that as, if there is anything as D there. Okay, D is H7. Okay, so it's not that, so I will now say this is equal to this here, is equal to this as D. Let me, so it has changed, look at it, has changed, G7 now, close. Now let me go back to this. Now I'll just say, I will use the D here now. Enter. So we have used the D there. Now this has no units, but let me format here. Let me format the whole thing. Now we are left with the next one is Reynolds number. So this is no, the next one is this equation. So we are going to move this right hand side to this other side. When you move it to this other side, this thing becomes plus. So it will be this plus this equal to 0. So that's supposed to be 0, that equation. Let me say, let me call it equation. There's no need to call it any other thing. Let me call it equation. Now say the equation is equal to 1 divided by the square root of f bracket close plus 2 times log to base 10. I have e divided by 3.7 divided by d plus 2.51 divided by this Reynolds number. I didn't define this again. Divided by this Reynolds number divided by square root of f bracket close so bracket close, another bracket close again for this other one. So now enter. So I have this is minus. So let me change this to Reynolds number. Let me use R. Sorry, capital R. Enter. Refuse. Okay. Let me see if okay. Let me see what I used before. I use this, so and this is H8. Now let me so equal to this. Click this good sign. So it has defined that. Now let me select this. Say use this in the equation. So enter. So that is that. Then I'll come here, select from format paint, select this. Now what I will use let me go to data. I will use solver to solve it. So I need to make this equation 0, right? Value should be 0. While changing the assumed friction factor. Now let me look at, okay, this one has the precision is high, so I will now solve. Okay, now if I solve, let me take these guys out a bit. Let me take them out. I will now call this. Let me copy this. Let me copy it to this place. Or this place. Paste. Now this one, make it equal to this. Now I change this to inches. Now we'll do this. I will say this is, let me say, equal to convert this, sorry, convert this, convert this, comma, this, select this. You can select it this way or you type, then comma, this other one is closed. Let me, so that should be n, select n3, enter. Now this is, so what will happen is that this is, I'll call this our results, call this results. I'll use this to format this stuff. Now I'll also copy this. Let me copy this. This is supposed to show here as result, so paste. Now I'm supposed to also copy. There is no velocity. Do I need velocity here? Okay, let me leave it for now. After all, is pipe size now 100. So what I'll do now is I will just say this is equal to this. Now we'll select this, go to data solver, select this, which has been selected, the 0. This is F is this, the assumed frictional factor. Then I'll just say I've checked this, I say solve. There is an error, solver encounters an error value. Okay. Divided by 0. Unless there is a mistake here, let me see. I said 1 times. This is supposed to be 1 divide. That was why there is a mistake. Supposed to be divide. Let me check again. Let me see. Let me see this. This is 1 divided by this. Divided by this plus 2 times log 10 divided by divided by this plus this divided by Reynolds number divided by square root of this. I went and did times, so that was why there is an error. So let's run it again. This is solver. this, just the same thing that's been selected. So okay, now let me just click solve. Okay, so it was properly done. You have 936,955.5. Now here you have, okay, let me expand it. Let me just increase the font. So this is it. Now let me just reduce it. This is 19.25. Then this one, okay, so let me now we have this 90. Now let's look at this one. This one will give us this is 1, this is 5700, this is 1, this one is 0.002, this is 2500, this is 12.98. Now I say solve. Yeah, will give me 19.25. This one will give me 6.29. This gives me 0.0136. Now, okay, let me check the, okay, look at the friction. Now let me just say, make all this the actual friction factor. Let me just format this whole thing. Now I have should be equal to this, which if you reduce it to 4 place or decimals, you see, it's the same thing with this. It's the same thing with this. Now this one is 936,955, which is also the same thing with this. Then this is 6.29. This one is okay, correct. This is 6.29. Let me see the flow velocity. Let me see the fluid velocity. The fluid velocity now should be equal to, and this should be in feet. Now it should be equal to, let me remove this. Now the velocity is should be equal to 4 times Q divided by pi divided by d raised to power 2. for, yeah, that's it. So this is feet per second. Now if you format with this, now you see we have 6.29, and my this thing is also giving me 6.29. This one is giving me 6.29. This is the same thing with this, almost the same thing with this and this. So this is it. So let me can close here, and I'll close it now. Thank you for watching. Thank you also for watching till the end. Have a nice day. Then in the next video I will show how how to also use MATCAD to solve this, to do pipe sizing. I don't want to extend this video so much, so let me end it here. Thank you for watching.